play a game today. You ready?
Yeah.
Alright. This is how it's gonna go. I'm gonna give you a little cup. That's your little cup. I have my own. You have yours. We also have 2 containers and they have water. I just put some food coloring so that we could see how much water we both have. Would you say that we have an equal amount of water right now? Both of us. Let me see. You're not gonna check? Yeah? Because the goal of the game is for you to empty all of your water up to my container, or maybe I end up putting all of my water into your container, but you're not allowed to move the container. You're not allowed to tip it or move it or pick it up in any way. Your only option to actually get this water to my container is this cup.
What about my hands?
No hands, the cup.
Okay.
Nobody's gonna end up like wet or anything. Okay? Ready? Are you ready? Okay, here we go. Who's gonna win?
Me.
Alright, ready, set, and you're too polite. Okay. Alright, who's winning? Okay, wait one. Let's see. Does it seem like any of us is like getting ahead? Maybe we have to go faster. Can you go faster?
Yeah. 3, 2, 1.
Okay, stop. Yep, return. Stop. Is it?
She won.
No, I mean maybe a little bit, or maybe you needed to put that cup over here, but we still have like, this is like, we still about the same amount, right? So what's happening is that I am able to put this much water onto your container just as fast as you're returning that same amount of water to me. So I'm putting this amount of water to you at the same speed that you're returning that water to me, right? So can anybody win?
Yes, if they add a bigger cup.
Oh, okay, all right. I agree with that. Let's look into that in a second. But first, let's see how this can actually relate to a reaction. Because if we could think about this like a reaction that's going forward and going in reverse and going forward and going in reverse, these first things that we have at the beginning of the equation would have to be the reactants. I'm going to label it, yeah? And you're actually the products. Are you ready for that? Can you put your label on? These are reactants. And those are products. You ready? Okay. All right. And then, so basically these are reactants becoming products, and these are the products becoming reactants because they're going forwards and backwards, right? This reaction happens to be reversible. It goes both ways. Okay. Now, so you're saying that you could win if you had a bigger cup? Okay, go get a bigger cup. Oh, okay. I have faith that I can make this work for me. So same rules, you can only use your cup, you cannot tip the containers, and we're gonna start this again, okay? Are you ready? Okay. Oh, gosh. This is not looking good for me. But I'm not giving up. I'm moving the reaction forward. And you're moving the reaction in reverse. Moving it forward. With that big cup, you'd think you'd be finished by now.
Yeah, because you can't really. It's hard.
What's the problem?
It's hard to get it from. It's so low.
It's so low, and you can't tip the container, right? That's the rule. So, do you think that? Do it again, one more time. No.
Go back.
I have the right. You can't interrupt my pro. All right, stop. All right, so obviously there are way many more reactants than we have products. Is that clear? For sure. But at this point, let's do it like 3 more times without interrupting each other. So I'm gonna go 1 and then 2 and 3 times. So go try your best to get as much of the products into reactants, and I'm gonna make as many reactants as I can. This is the topmost amount because that's the size of my cup. Yeah, and I am going to, and you guys check out our volume, like how much water do we have every time. One more time. that's it. Okay, so do you see what happened? Like, you see how you can't win? Only because this amount of products is always going to be there. This seems to be about the amount of products that you had before. This is the amount of reactants that I had. Obviously, they are not equal, but you know what has happened? Now they've become constant. They've become constant. The amount that they have doesn't really change. They're definitely not equal. I have more reactants, you have less products. But they've become constant because, like, when you try to get as much water there, and I try to get as much water in mine, basically they're still the same amount, right? Because you have that problem that you can't really fill it up completely. So right now this reaction is going forward and is going in reverse, but the amount of products and reactants is not equal, it's actually constant. What is equal? The speed that I'm going this way, does it seem to be the same as the speed that is going in reverse? Yeah? And that's why the amounts are actually constant, because the speed of going forward and going in reverse, it's actually equal. Does that make sense? You know what we call that?
What?
We call that a system at equilibrium.
Wow.